determine the appropriate wire size for a 150 amp subpanel being fed from a 200 amp main, you must consider the ampacity, which is the current carrying capacity of the conductors, and the potential voltage drop. The fact that the main panel is rated for 200 amps only tells us the maximum the service is designed to handle. It does not mean the subpanel feeder needs to be sized to that. The 150 amp subpanel indicates that the branch circuit to the garage should be sized to handle a maximum current draw of 150 amps. Voltage drop is the reduction in voltage as current travels along a conductor. Minimizing voltage drop is crucial for the correct functioning of electrical equipment. When using direct burial cable, the ampacity is less than that of conductors in copper pipe due to heat buildup. Therefore, a larger conductor size is necessary. In this scenario, a 500 kcm aluminum cable is recommended for direct burial. If using copper conductors in a copper pipe or conduit, the ampacity is higher because the pipe or conduit helps dissipate heat. In this case, a 350 kcm copper cable is adequate. It is crucial to select the correct wire size and type for the application to ensure safety and optimal performance of the electrical system. Factors such as the material of the conductor, aluminum or copper, the insulation temperature rating, the ambient temperature, and the method of installation, direct burial versus in conduit, all influence the ampacity of the conductor. Firstly, consider the ampacity requirements. The conductors must be capable of carrying the expected load current continuously without exceeding their temperature rating. For a 150 amp subpanel, the conductors should have an ampacity of at least 150 amps. However, it is good practice to size the conductors slightly larger to account for future load growth or potential voltage drop issues. Secondly, evaluate the voltage drop. Excessive voltage drop can cause equipment malfunction, reduced efficiency, and premature failure. The National Electrical Code, or NEC, recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Calculate the expected voltage drop based on the conductor size, length of the run, and the expected load current. Adjust the conductor size as needed to meet the voltage drop requirements. Thirdly, select the appropriate conductor material. Copper and aluminum are the most common conductor materials used in electrical wiring. Copper has a higher conductivity than aluminum, meaning it can carry more current for a given size. However, aluminum is less expensive and lighter than copper. When using aluminum conductors, it is important to upsize them to compensate for their lower conductivity. Refer to the NEC ampacity tables for the appropriate ampacity ratings for copper and aluminum conductors. Fourthly, consider the insulation type and temperature rating. Conductors are insulated with various materials such as thermoplastic, thermoset, and rubber. Each insulation type has a different temperature rating, which indicates the maximum temperature the conductor can withstand without degrading. Select an insulation type that is suitable for the operating environment and the expected temperature rise. Refer to the NEC for the allowable ampacities of conductors based on their insulation temperature rating. Fifthly, factor in the installation method. The way conductors are installed can affect their ampacity. Conductors installed in conduit or cable trays have a higher ampacity than conductors installed in free air. This is because the conduit or cable tray provides a path for heat dissipation. Direct burial cables have a lower ampacity than conductors installed in conduit because the soil surrounding the cable can trap heat. Refer to the NEC ampacity tables for the appropriate ampacity ratings for conductors based on their installation method. Sixthly, account for ambient temperature. The ambient temperature is the temperature of the surrounding environment. High ambient temperatures can reduce the ampacity of conductors. This is because the conductors cannot dissipate heat as effectively in hot environment. Refer to the NEC for ampacity correction factors that must be applied when the ambient temperature is above 30 degrees Celsius or 86 degrees Fahrenheit. Seventhly, direct conductors for multiple conductors in a raceway or cable. When multiple conductors are installed in the same raceway or cable, their ampacity must be derated. This is because the heat generated by each conductor can raise the temperature of the other conductors, reducing their ampacity. The NEC provides directing factors that must be applied based on the number of current carrying conductors in the raceway or cable. Eighthly, consider the termination temperature rating of equipment. Electrical equipment, such as circuit breakers, switches, and transformers, has a termination temperature rating. This rating indicates the maximum temperature that the equipment's terminals can withstand. The conductors connected to the equipment must have an insulation temperature rating that is equal to or higher than the equipment's termination temperature rating. This is to prevent the equipment from overheating and failing. Ninthly, check for any local codes or regulations. Local codes or regulations may impose additional requirements for conductor sizing or installation. Be sure to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Tenthly, use a qualified electrician. The electrical work can be dangerous and should only be performed by a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely and effectively install electrical wiring. They can also help you select the appropriate conductor size and type for your specific application. The selection of the correct conductor size for a 150 amp subpanel involves a careful consideration of several factors, including ampacity, voltage drop, conductor material, insulation type, installation method, ambient temperature, directing factors, termination temperature rating, and local codes. Following these steps will ensure that the subpanel is wired safely and correctly. The National Electrical Code, or NEC, provides specific guidelines for determining conductor ampacity based on factors such as insulation type, ambient temperature, and the number of conductors in a raceway. For example, NEC Table 310.15 P16, formerly 310.16, provides ampacity ratings for conductors based on the insulation type and temperature rating, assuming an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher, correction factors must be applied. NEC Table 310.15 B3 A, formerly 310.15 B3R, provides adjustment factors for the number of current carrying conductors in a raceway or cable. These factors reduce the allowable ampacity of the conductors to prevent overheating. Additionally, voltage drop calculations are crucial to ensure that the voltage at the subpole remains within acceptable limits. The NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is a constant representing the conductor material, typically 12.9 for copper and 21.2 for aluminum, I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor. By plugging in the appropriate values, you can determine the voltage drop for a given conductor size and adjust accordingly. In this specific scenario of running a 150 amp subpanel from a 200 amp main, the choice between direct burial aluminum cable and copper and conduit depends on several factors. Direct burial cable is typically less expensive to install as it eliminates the need for conduit. However, it has a lower ampacity rating due to the soil's poor thermal conductivity. Therefore, a larger conductor size is required to achieve the same ampacity as copper in conduit. Copper in conduit offers better heat dissipation, allowing for a smaller conductor size. However, the cost of the conduit and installation can be higher. When using direct burial aluminum cable, a 500 kc male conductor is generally recommended for a 150 amp subpanel. This size provides adequate ampacity and minimizes voltage drop. When using copper in conduit, a 350 kc mil conductor is typically sufficient. This size offers a good balance between ampacity, voltage drop, and cost. Always consult the NEC and local codes to ensure compliance with all applicable regulations. It is also advisable to consult with a qualified electrician to determine the most appropriate conductor size and installation method for your specific situation. Choosing the correct wire size is critical for safety and performance. Undersized wires can overheat, leading to insulation damage, fire hazards, and equipment malfunction. Oversized wires can be more expensive and difficult to install. By following the guidelines outlined in the NEC and considering all relevant factors, you can ensure that your subpanel is wired safely and efficiently. Remember to always de-energize the circuit before working on any electrical wiring. Use appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Safety should always be your top priority when dealing with electrical systems. This ensures the longevity and safety of the electrical installation. Remember to check local codes and regulations, which may have stricter requirements or specific rules regarding wire sizes for subpanels. Local electrical inspectors can provide guidance on these matters. Consulting with an electrical engineer or experienced electrician can also offer valuable insights and ensure compliance with best practices. The goal is to create a safe, reliable, and efficient electrical system that meets the demands of the subpanel while adhering to all applicable standards and regulations. Always prioritize safety and seek professional assistance when needed.